Good afternoon, students, and welcome to this afternoon's class. Today, we'll be continuing our discussion on estimation. Do remember that in some of our previous videos, we already had started looking at estimation in terms of the introduction. We equally had looked at different kinds of estimations we have in terms of the point estimation and the interval estimation. In some of our videos already, we had discussed point estimation in detail in terms of introduction. We equally had discussed the interval estimation in terms of introduction. And we have started taking some examples on interval estimation. But today, this afternoon, we want to squarely discuss the interval estimation for the difference between two population means. Therefore, we encourage you that a situation whereby you are just joining us today, that you do subscribe to our YouTube channels and then see all our videos lined up on YouTube. So you'll be able now to go to these classes we made reference to and be able to see if going through them before this class will be of help. But of course, we are confident that even when you have not had opportunity of going through those videos, that you still make a lot of sense from what we are going to discuss this afternoon. So what we have this afternoon is interval estimation for the difference between two population means. Interval estimation. Interval estimation for the difference between two population means. Population means. So the question of interest is, how do we construct confidence interval for the difference between two population means? Things that are going to be of importance for the beginning of this class is one, noting that there are two populations here involved. And then we can tag those populations as population 1 and population 2. Permit me to write them this way. We have population 1, POP what? 1, referring to the first population. Then we have what we call population 2. We have POP 2, referring to what the population what 2. This population 1 have parameters. Of course, those parameters are, we have what we call the mu 1, which is what? The mean of the population 1. And then we have what we call sigma 1 square, which is referring to the variance of the population 1. And then we equally come here, we equally have what we call the mu what? 2, referring to the mean of population 2. And then we have what? Sigma what? Square what? 2, referring to the variance of what? Of population what? 2. So the interest here is that we want to construct confidence interval that will be able to bound the difference between these two population means mu 1 and mu 2 with a certain level of what? Of confidence. So the difference between the two population means we mean is that at the center here, let us now tag it to the what? Mu 1 minus what? Mu 2. This is what we want to construct a confidence interval that will be able to what? To contain it. And do remember that when we began this interval estimation, we said that for us to construct the confidence interval that will contain the unknown population parameter in terms of what? Of intervals, that we are going to represent this interval with what we call L1 or what we call L and what? And U, where L is what we call the lower confidence limit and then U is what we call the upper confidence limit. And then we wrote something like this that time, we say that we have what we call what? U, what we call what? L less than or equals to what? Theta less than or equals to what? U. We call this L that time the lower confidence what limit, and then this U the upper confidence what limit. And this is the population parameter of interest called theta. And we say that this population parameter theta here could be the population mean when we are discussing a single population, or it could be the difference between two population means when we are discussing two populations. It could even be the population proportion or anything. So it is just written here to represent any population of what of interest. This time around, the population of interest which we want to estimate is the difference between the two population what means. So when we come down here, what we are going to have is that we are going to have what? L here less than or equals, I am no longer going to put what theta because our interest here is on the difference between the two population means. So I have what we call what? Mu what 1 minus what? Mu what 2 is less than or equals what? U. So this becomes what we call the confidence interval for the difference between the two population means. And we equally need to say that for us to construct this confidence interval L and U to contain or bound the difference between the two population mean, we have to do it with some level of assurance that at the end, our interval constructed will be able to contain this difference between the two population means. And of course, this statement now brings in the idea of probability. And then we begin to talk about what? That the probability of L less than or equals to what? Mu what 1 minus what? Mu what 2 being less than or equals to what? U is now going to be given as what? 1 minus what? Alpha. Remember that we already had called this 1 minus alpha in one of our previous videos as the confidence level. That is to say that we are 1 minus alpha confident that our confidence interval L and U are going to contain the difference between the two population means, the mu1 minus what? Mu2. Or the probability that our confidence limit L and what? U contains the difference between the two population mean will be given as 1 minus what? Alpha. Where, of course, we earlier had said that this alpha is what we call the level of significance, which is the probability that our confidence interval L and U fails to contain the population parameter of interest. And that is the reason why this value is always limited as a very small quantity, 0.01 or 0.05 as the case might be. So the question becomes, given these explanations or this introduction, how do we find the true value of what? Of L and U, such that these values L and U will be able to contain the difference between the two population means given this probability level. That is our interest. Estimating the lower and the upper confidence limits in such a way that we are 1 minus alpha confident that they are going to contain our unknown difference in the two population what means. We are going to make these discussions under 4 categories. That is the reason why I devoted this class purely for interval estimation for the difference between two population means. So we are going to do this construction now under 4 different conditions. So let us go through those conditions before we begin to take questions together. So permit me to clear here. And permit me to equally clear here. . The first condition we are going to consider is when the sample sizes that are taken from these two populations are large and the two population variances, sigma 1 squared and sigma 2 squared, are known. I will write it on the board. That is number one scenario. You see, when N1 and N2 are large, are what? Large. And sigma 1 squared and what? Sigma what? 2 squared are known. This is the first condition. So the question becomes, N1 here means the sample size taken from population 1. N2 here means the sample size taken from population 2. Sigma 1 squared here is the variance of the population 1. And then sigma 2 squared here is the variance of what? Of population 2. And in one of our previous videos, we already had stated that we refer the sample size n to be large when that sample size n is greater than or equal to what? 30. So for us to say that N1 and N2 are large here, we are implying that N1 is greater than or equal to what? 30. And what? N2 is greater than or equal to what? 30. That is what we are implying here. So the question becomes, under these conditions now, what do we do? How do we construct the confidence interval that will contain the difference between the two population what means? The very first thing we are going to do is this. We are going to take sample from, let me call this POP1 as usual, POP1. Let me call this one POP2, POP what 2. We are going to take sample from population 1 and take sample from population what 2. And bear you in mind that this population 1 has mean mu 1, of course. And then the variance is given as what? Sigma 1 what? Squared. And we are glad because we are told in this condition that they are what? Known. Equally here, we know that this one has what? Mu what? 2. And then the variance is what? Sigma what? 2 all squared. So this is what we have. So the sample we are going to take from population 1, we call it what? X bar what? 1, 1. So X11, X12, down to what? X what? 1n. Let me explain what we mean by X11. That is the first observation from population 1, second observation from population 1, down to nth observation from population 1. That's what we mean by X11, X12. Then we equally come here and we take a sample X21, X2 what? 2, down to X what? 2 what? N. That is first observation from population what? 2, second observation from population 1, 2, down to nth observation from population what? 2. I believe we are still together. From these samples taken, it is believed that our N1, because here, let me put here to my N1, so I know what we mean by this. Let me put this into the N2 here. So that this our N1 here, of course, is greater than or equals 30. And this my N2 here is greater than or equal to 30. That is now the condition what? 1. Sigma 1 squared and sigma 2 squared are known. N1 and N2 are what? Are large, such that they are greater than or equal to what? 30. And our interest is that we are now It is now from this now, sample 1, you are going to estimate the sample mean of population 1, which of course you know is given as what? X bar 1. You equally come here and estimate the mean from the sample of population what? 2, which you know is going to be what? X bar what? 2. And your interest is that you are looking at probability that L is less than or equals to what? Mu 1 minus what? Mu what? 2 less than or equals to what? U with the probability of 1 minus what? Alpha. How do we get the true value of this L and the true value of this what? U to satisfy this condition under this condition? For us to get a value of L and U that will satisfy this condition under this condition, the value of our L and U must be our L. Our L is going to be, you open a bracket, this is X bar 1 minus X bar what? 2, close the bracket, minus Z of alpha over what? 2 general square root of what? Sigma 1 squared all over what? N1 plus sigma what? 2 squared all over what? N what? 2. This is going to be the value of what? Of L1. Our L2 will be, sorry, our U will be, the only thing that will change in the entire of this formula is this sign. Everything remains the same. So we now have this. This is X bar 1 minus X bar what? 2, close the bracket. Here was minus before, it becomes plus. You have now plus Z of alpha over what? 2, general square root of what? Sigma 1 all squared all over N1 plus sigma what? 2 all squared all over what? N2. This is how it is going to be. There is a way at times that they present this in a textbook, which of course I want to show you exactly how it is done here. You know, the only sign that changes here is this. Here is minus and here is what? Is plus. So you can easily come and say that the value of what? Of L and U that will satisfy this condition is, you have L, you open a bracket, L, comma what? U is going to be, here you have this, you open a bracket, X bar 1 minus X bar what? 2, close the bracket. You come here, you write plus minus. This plus minus will take care of this place and this place. So the only point remaining is here. You have this thing this way. So you have what? Sigma 1 all squared all over N1 plus sigma 2 all squared all over what? N what? 2. So when you are talking about L, you are now paying attention to this what? Minus, which is what is here. When you are talking about what? U, you'll be paying attention to plus. You arrive at what we have here. So whenever they give you a question and they tell you that the sample from population 1 and the sample from population 2 are large, and the variances from these two populations what are known, this is the formula that you are going to use. This is the formula you are going to use. So the only thing I beg you to remember for me is this formula. That's the only thing I beg you to remember for me. This formula. Remember this formula. So we are going to clean this. Take condition 2. Write what we have for it. Take condition 3 and take condition 4 before we begin to take examples. And let me increase the speed so that we can manage the size of our videos. So permit me now to clean here. The second condition we have, I'm going to put it as question number as number 2, is when n1 and n2 are large and sigma 1 squared and sigma 2 squared are unknown. They are what? Unknown. Before, they were known. This time around, unknown. So the only thing that changed from condition 1 and condition 2 is that in condition 1, we are given the values, or the values of a sigma 1 squared and sigma 2 squared were known. But this time around, their values are unknown. How do we do this time around? When this kind of thing happens, what we are going to do is this. We no longer know sigma 1 squared, we no longer know sigma 2 squared. Okay? So we now come here. Permit me to clean here. The only thing you estimated from this sample before was the x bar 1. You did not estimate sigma 1 squared because you knew it or it was given to you. But this time around, it is not known. So you are going to estimate it from this sample. And when you estimate it now, you are not going to write as sigma again. You are going to write it with s squared. Because you are not going to write it as something like this, s1 squared. Because the variance for population is written as what? Sigma squared. But then the variance for sample is written as what? S squared. You equally did not estimate it here because it was known that time. So this time around, we are going to estimate it and you have what? S what 2 what squared. Okay? Now, you move ahead. Ahead you are going to move is this. Remember that your interest still remains at that you are looking for what? For P, okay, such that L is less than or equals to what? Mu what? 1 minus mu what? 2 less than or equals to what? U, that will satisfy the condition y minus what? Alpha. So the concern becomes, what is going to be the true value of what? L and U that will satisfy this confidence what level under this condition. The value of our L and U will be given this way. Without wasting much of your time, I am going to use that our L, comma U. So it is going to be L, open a bracket, comma what U is given as. Open a bracket. You still have your x bar 1 minus your x bar what 2, close the bracket, plus minus. You still have your z of alpha over what? 2, general square root of what? S1 squared all over what? N1 plus S2 what squared all over what? N2. You find out that the only thing that changed here is here in our first condition was sigma 1 squared. This place was sigma 2 squared. But what we are having here is what? S1 squared and S2 squared. Because we are not given that in the question, we estimated it from what? From the samples which we drew from population 1 and population 2. And of course, we should be working with what we know because we were not given that thing. So whenever this condition surfaces for you, yeah, you now resort to using this particular formula. Okay? That is what happens under condition what 2. I want to believe it is clear. So permit me equally to wipe this entirely, and then we now move over to the third condition. The third condition is something that is going to involve a little derivation, but it's not going to be difficult. So permit me to clean here. You have already known how to take sample from population 1 and population 2. You have already known that there are two populations, population 1 and population 2. So permit me to clean it now so that the other one is going to be a little bit longer. So I'll clean it. Then we have entered the third condition. And the third condition here is N1 and N2 are small, okay? But they are assumed to be equal. N1 and N2, sorry, are small, and population 1 and population 2 are unknown but assumed to be equal. That's the condition we have. N1 and N2, small. Population 1, variance of population 1 and population 2, unknown, but they are assumed to be equal. So that's the condition. That is number 3. Maybe you put it this way now, you have already known what I mean. N1 and what? N what? 2 are small. You already know what I mean by this. Okay? We now say sigma 1 squared and sigma what? 2 squared are unknown. Are unknown, but assumed to be equal. But assumed to be equal. Assumed to be equal. How do we go about getting the value of our L and the value of our U that will still satisfy that condition under this condition? That is, that we are still interested in our P of L less than or equals to what? Mu 1 minus what? Mu what? 2 less than or equals to what? U, which is equals to 1 minus alpha. What is going to happen here when we have this kind of condition? What's going to happen here in this condition is, because they are assumed to be what? Equal. You see, they are assumed to be equal, but they are unknown. We are going to estimate the common variances. I use the word common here because they say they are assumed to be what? Equal. So we now say we estimate the common variance. Estimate. Estimate. Estimate the common variance with SW squared. We are going to explain in detail what we mean by SW squared. Okay? So, if you estimate the common variance with SW squared, then we go ahead now to go and get the value of our L and U. And remember that at the beginning of our class on interval estimation, on estimation in general, we said it clearly, okay, that whenever our n is large, n is assumed to be large when it is greater than or equals to what? 30. And when this condition is met, we now say that we can apply what we call the central limit theorem. And because of the application of the central limit theorem, then we say we can use the standard normal distribution in obtaining the critical value of the confidence limits. But this time around, we have been told that N1 and N2 are small. When N1 and N2 are small, we no longer use the standard normal distribution to obtain the critical value of the confidence limit. Instead, we use what we call the student T distribution. So this time around, we are not going to use Z of alpha over 2. You have seen me writing. We are now going to use T this time around. So what we are now going to have is our L, we open the bracket, L, comma what? U, here now is going to be. We still open the bracket and have what we call x what bar 1 minus x bar what 2, close the bracket. Then we have what we call plus minus. We have what? T of n1 plus n what 2 minus 2. Then alpha over what? 2 general square root of SW all squared all over N1 plus SW all squared all over what? N what? 2. You find out here that here now, I am not saying S squared 1, S squared 2, because they say they are assumed to be equal. So population 1 has variance of SW squared, population 2 has variance of SW what squared. Then this is the formula we are going to use. Note, this N1 plus N2 minus 2 is called the degrees of freedom. So when they're asking you a question about two populations and then the population sizes are small such that are less than 30, and after asking you, they begin to say, what is the degrees of what freedom? Degrees of freedom is the N1 plus N2 minus 2. That is the sample of population 1 plus the sample of population 2 minus 2. Whatever thing it gives you is what we call the degrees of what of freedom. But we are going to adjust this formula small because we can do some factorization here. The factorization we can do here is this. In as much as there is SW squared here, SW squared here, we can bring it out. Bringing it out now, what we are now going to have becomes what? We have x bar 1 minus x bar what 2, close the bracket, plus minus. We still have t of n1 plus n what 2 minus 2 of alpha over what 2. We now have what we call square root this way. We now have what? SW squared. We open a bracket. Because I brought this in out, what is going to remain here is 1 all over what? N1 plus 1 all over what? N2. We close the bracket. If you want to return back, you use this to multiply this, you are here. Use this to multiply this, you are here. And you return back that place. So it's not really difficult. Now, and you remember that you are taking square root of something that has what? Power inside. It has raised to power, is raised to power 2 inside. So if you are taking square root of something that is squared inside, of course, that thing comes outside fully. So that this formula can fully be written out. This becomes, you open a bracket. This is x bar 1 minus x bar what 2, close the bracket, plus minus. You have t of n1 plus what? N what 2 of alpha over 2 minus what 2. You have SW, general square root of 1 all over N1 plus 1 all over N what 2. Permit me to remove what came up on my screen. So you now have this. Now the question is, having written this thing, what is our SW? How do we express our SW? So we are now going to say where our SW equals general square root. You see what I wrote? For general square root, you open a bracket, n1 minus 1, s1 all squared plus. You open a bracket again, n2 minus 1, s2 all what squared all over. You now have what we call n1 plus n what 2 minus what 2. So for you to estimate this SW, you are going to use this formula. This formula estimates this SW before you now begin to put them in these places to evaluate this. So this is what you do in the third condition. And that third condition is when N1 and N2 are both small, the population variances sigma 1 squared, sigma 2 squared are unknown, but they are assumed to be equal. Okay? So permit me to clean this place. Okay? Then we now write down the fourth condition before we now begin to take a question. The fourth condition is almost the same thing here. Our N1 and N2 are still small. Okay? Sigma 1 squared and sigma 2 squared are still unknown. But this time around, they are assumed to be unequal. They are assumed to be unequal. They are not equal. So because they are unequal, you are now going to say you are going to estimate their common variance. You can't estimate their common variance again. The formula you are going to use in this time around to arrive at the true value of your L and then U that will satisfy this condition will be, what you are going to have is, you have L, comma what? U, which of course is going to be, still you open your bracket here, x bar 1 minus x bar what? 2, close the bracket. Then plus minus, you have what? T of what? V of alpha over 2, then square root this way of what? S1 all squared all over what? N1 plus S2 all squared all over what? N what? 2. This is the formula you are going to use this place. The only thing challenging here is that there is V here, and this V here is still called the degrees of what? Of freedom. But we need to estimate these degrees of freedom. It's not going to be as we saw in the third condition that was just simply N1 plus N2 minus what? 2. We are going to estimate it that way. And the formula with which to estimate this V, we now say where V, we say where our V equals, we have our S1 squared all over what? N1 plus S2 all squared all over what? N what? 2, this way and this way, then all over. Okay? Open a bracket here. You have S1 squared all over what? N1, close the brackets, then plus. You have what? S what? 2 here, all squared all over what? N what? 2. Here is squared, close it, here is squared. You have here all over N1 minus 1. Here you have N2 minus what? 2. Then you now have something like this. So this is what you have. So this is what you use to estimate that thing. Okay? So if you want to get the true value of this V, you use this formula and you arrive at the true value of that V, and that will give you exactly the correct answer. Here, I think we have, yes, not I think, there is a square here. There is a square there. So I know you very much well that when you find the value of this thing now, you round it off to the nearest whole number. You round it off to the nearest whole number. So it can help you to go to the T distribution table to go and read off the critical value of the confidence limits. So you have now seen condition 1, condition 2, condition 3, and condition what? 4. Thank you very much. We are going to wipe the board entirely, and then we just take 2 questions, and then we see how those 2 questions can help us. So permit me to clean here while we take those 2 questions. Okay? Okay. Look at the question. Look at the question. The question says the results of an experiment involving 2 populations involving 2 populations is summarized is summarized is summarized as follows. We have population 1. First of all, we have POP 1, POP what? 1. Then we have POP 2. We have POP 2. Underlined. Then here I have what we call sample size. Sample size. Here I have sample mean. Sample mean. And here I have sample standard deviation. Sample, please permit me to write STD, sample standard deviation. Okay? Under here, I have that N1 equals what? 9. Under here, I have that N2 equals what? 16. Under here, I have that X bar 1 equals what? 96. Here, I have that X bar 2 equals what? 50 what? 1. Then under this place, I have that S1 equals 36. And under here, I have that S2 equals what? 36. Okay? And then the question they ask is this. Assuming that the two populations are independent and normally distributed. Are independent, permit me to write ID here to mean independent, and normally, permit me to write this now, normally distributed. With condition A, equal but unknown variance. Equal but unknown variance. Condition B, unequal but unknown variance. Unequal but unknown variance. They say set up. The question says set up a 95% confidence interval. This is confidence interval for the difference between the two population means. POP means. Want us to internalize the question very well. Once we internalize the question very well, then we wipe the board or we clean this question down and tell ourselves how to go about it. You see, they say the result of an experiment involving two populations are summarized as follows. This is population 1 and population 2. This is the sample size. Sample size of population 1 is 9. That of what? Population 2 is what? Is small. So looking at them, first of all, we know that they are small samples. It's clear. None is up to 30. So we hold that one at hand. The sample mean here for population 1 and see sample mean of this one is this. Standard deviation here is 36. Standard deviation here is 36. So assuming that they did not even give us these conditions here, equal or unequal, by real sense of it, now we are going to treat as if to say they have equal variances. They are assumed to be equal. You understand? They are assumed to be equal because you see that this is 36 and 36. But whichever way you see it, even if you see 4 and 4, 5 and 5, what would the conditions now, the question that are giving you this place, or they're asking you this place? So they now come down and say, assuming that the two populations are independent and normally distributed, with condition A equal but unknown variance, B unequal but unknown variance, set up a 95% confidence interval for the difference between the two population means. So the first thing we are going to do is, we now come to this A, we look at it, we say at which condition does this A fall in the four different conditions that we earlier had explained. Here, the variances are unknown, but they are assumed to be what? To be equal. We remember that condition. And I'm going to write it because that thing fall under what? Under condition what? 3. Condition 3, because the sample sizes are small. The variances are what? Are unknown, but they are assumed to be what? To be equal. And we remember the formula where we can use to estimate the lower and the upper confidence to estimate the lower and the upper confidence limits. Sorry for that. So what I'm going to do is to clean the board. Here, let me clean the board. This place. So what we are going to use is condition 3. And that condition 3 says, that our L and U will be given as x bar 1 minus x bar what? 2 plus or minus, we have what? T of what? N1 plus N what? 2 minus what? 2 of alpha over what? 2 S of what? W square root of 1 all over what? N1 plus 1 all over N2. This is the formula. We just explained this formula in the third condition. Now you know x bar 1, 9. You know x bar 2, 16. You know x bar 1, sorry, 96. You know x bar 2, 50 what? 1. You know N1 to be 9. You know N2 to be what? To be 16. The only thing that is going to pose a challenge here that you don't know S of what? W, and you don't know what? Alpha. But because they ask you that alpha, that you should set up 95% confidence interval, 95% confidence interval, you should now know that your alpha is going to be 0.05. We earlier had explained this thing in some of our previous videos. So I still recommend the previous videos to you if you find it difficult on why this alpha should be 0.05 when you are asked to set 95% confidence interval. So alpha is 0.05, but you don't know what is this your S, what W. And you remember that I gave you a formula for SW, where we now say SW, S of W is given as, we say general square root. You open a bracket, you say N1 minus 1, S1 all squared, all over, yes, plus, you open a bracket, N what 2 minus what 1, S2 all what squared. General all over, N1 plus N what 2 minus 2. There is nothing you are looking for here to estimate W that isn't given here. N1 is here, N1 is here, N2 is here, N2 is here. S1 squared is here, S1 is here. So for you to get the S1 squared, you are going to square this 36. That's the implication. So if you have to square this, you have to square this. squaring both sides. So you have to square this. Then you square this one equally for you to get your S towards W. Then here, of course, is your N1, which is this 9, N2, which is what? This 16. And this estimation, after they put it inside, put all this in inside, they told us that this place is given as a 36. So you can try and confirm your own, whether after putting these values now that you are going to get that SW is what is 36. You can confirm it, that SW equals what? 36. So I'm now going to clean here up now. Then we now come over here. And before we come over here, we should now know that our N1 plus N2 minus 2. N1 is what? 9. So if I want to get that value now, I have N1 plus N2 minus 2, which implies that N1 is what? 9. I have what? 9 plus. N2 is what? 16. I have 16 minus what? 2. 9 plus 16 here now will definitely give me what? 9 plus 16 will give me what? 25. So I have that this becomes what? 20 what? 5 minus what? 2, which gives me what? 20 what? 3. So I have known that this N1, that my N1 plus what? N what? 2 minus what? 2 is going to give me what? 20 what? 3 is equals 23. So I will now come here and begin to do my thing. Of course, you know that my x bar 1 minus x bar 2, x bar 1 is what? Is 96. So I will now come here and clean this board. Permit me to clean this board. Permit me to clean this board here. So I will now come here and say, therefore, this is equals, you open a bracket. X bar 1 is 96. You have what? 96 minus. X bar 2 is what? 51. 5 what? 1. Close the bracket. Plus minus. Here is your t. So you have your t. The whole of this thing has become 23. You have what? 23. This is alpha, which is 0.05. 0.05 divided by 2 will give you what? 0.025. So you have what? 0.025. Then your SW is already 36. You multiply by what? 30 what? 6. General square root of. Here is my 1 all over what? 9 plus 1 all over 16. 1 over 16. So what this means is, once you pick up your calculator, you say this minus this, you drop the value here. Okay? Then you now come here, you go to student T distribution table to go and read up this value. Even though the value has been provided for us here, they gave us a value here. But if you go to that student T distribution at 0.025 level of significance, when the degrees of freedom is what? Is 23. You now read up what the value. You get the value, multiply it by 36, get the square root of this thing, and multiply it out. Then when you are now talking about getting L, it is whatever thing you get here plus whatever thing you get here. When you are talking about what? Sorry, when you are talking about L, it is whatever thing you get here minus whatever thing you get here. But when you are talking about U, it is going to be whatever thing you get here plus whatever thing you get here. And that becomes what the answer. So let us lift what they gave us, and I urge you to confirm whether what you are going to have at the end of it now is a 2. By their own calculation, they have that L this way, U is given as, they have 13.965 and then 76.035. This is what they have to be the lower class words, the lower confidence limit, and then the upper confidence limit. So you can evaluate this thing I have here, considering when this is minus. Evaluate this, and say what you have here minus what you evaluated here, and know whether you'll be able to have this thing. And then at the end, you equally do this minus this, evaluate this, and this time around add it now to know whether it is going to be that quantity. If it's not going to add up to that quantity, then it means maybe there is something that we did not consider right. Thank you very much for your attention so far. Okay, so let us now quickly clean the board and then look at the second condition when the other thing is when the that B part of the question that says that the N1 and N2 from here, N1 and N2 here are still small. That one we know it. And condition is two is saying that the variance of the two populations are unknown, but they are assumed to be unequal. Because this time, this one we considered here, they were unknown but assumed to be what to be equal. So let me quickly write the formula of that one and then we conclude the class. I am not evaluating this because if I go into detail evaluating it now, the size of the video is going to be too large and it's going to take bulk of our time. This time around, it is going to fall to condition 4, becomes condition 4. So under condition 4, we are going to use a formula that says that our L of what U is going to be. We still have what we call x bar 1 minus what? X bar what? 2 close it. We still have what we call plus minus. We have T V alpha over what? 2 square root of. We have what? S1 all squared all over what? N1 plus S2 all squared all over what? N1 2. So the only thing that you do not know here, so to say, is this your V. And I already had given us a formula for V earlier, that where our V, this our V is given as what? S1 all squared all over what? N1 plus S2 all squared all over what? N1 2. Open a bracket this way and then you square it. Then you open. Then you have something like this. You still repeat what you have here. S1 all squared all over N1. You close it. You square it. Then you come, you say plus. You come over here. Repeat what you have here. S2 all squared all over what? N1 2. Then you do this way. You square it. You say all over N1 minus 1. This one all over N2 minus what? 2. So in this way, this is how to get your V. Okay? And there is nothing you are looking to find here that has not been given here. N1 given. S1 squared. Because S1 here is what? Is 36. You are going to square it equally to put it here. S2, which is here, is given. Everything you are looking for from this place has been provided here. You understand? And then this thing has been evaluated and given to us to be, the value has been given to us in this test to be 16.71. 16.71. So you can try whether after fitting in these values here, you'll be able to get 16.71. And remember earlier that we said that once you get any decimal point, you try as much as possible to round it up to the nearest a whole number. So, and that will make this thing to be approximated to what? To 17. Because this 7 can round up. So it comes over here now and you have a 17. Okay? So, and then with this 17 you have, so we now know that our V equals what? 17. And as usual, we are still setting 95% confidence interval. And as such, our alpha is still 0.05. So we now clean this place. Clean this place. And we now say therefore. Now say therefore, our L and U is given as, here x bar 1 is what? 96. You have 96 minus. It is what? 50 what? 1, close it, plus minus. Here is my T. This my V is already 17. I have 17. Alpha of 0.05 divided by 2 will give you 0.025. I guess you can confirm that. Then you have now square root of. So here is my S1 squared. So you are now going to write that place now to be 36 all squared all over. N1 is what? 9 or 9 plus. Here, my S2 is still 36. You have what? 30 what? 6 all squared all over. N2 is what? 16 all over what? 16. So what you are going to do here now becomes, you are first of all going to get the value of L by evaluating this, dropping this value, evaluating this and dropping this value. At the end, whatever value you got here minus the value you got here will give you the value of what? Of L, lower confidence limit. Then at the end, whatever thing you got here plus whatever thing you got here will give you the value of what? Of U, the upper confidence what? Limit. Okay? So, because if we say let us be pressing calculator and be going to the end, it is going to cause troubles. So at the end, check whether what you are going to have is what they have in this textbook, and then the value they give here is very close to the values that we had earlier. The value they have here is that L of U is given as, open a bracket, here is 13.35 and then 76.65. This is what they have there. So after fitting in these values and having this, evaluating it, cross-check whether you are going to have something that is very close to this. Thank you very much for your audience thus far. Please do remember to subscribe to our YouTube videos and remember to turn on your notification bell. So that each time we upload a new class, you'll be able to get a notification. Okay? Thank you for today. The next time we are going to go over to estimation of the unknown population proportion. Thank you.